Hi, I will do a quick tutorial about the installation of ARES and a quick run with it. So for those of you who don't know, ARES is a code that it can be used to automatically measure the equivalent widths of absorption lines in stellar spectrum, which is ideal if you want to derive stellar parameters or chemical abundance for any kind of stars. The code can be downloadable in this web page. It's already been available for free for more than 5 years now. The code, in order to download the code, you just press here and then it will ask you to fill a form and give your identification. This is just for me to get some track on the downloads of the code. So once you fill the form and you press the download button, you will download a file that has this form here, ARES version 1.0.tar. So just to show you how easy it is to install ARES, you just can copy this file for the ARES folder, go in there, and to unpack this very easily, just do this and you will get some files that came inside the package. It came the code itself, it is a C code, not a C++, it is written in the paper, but you also have a FITS file with a spectra from the sun using the reflected light in Ganymede, and some output file that you should just do a copy of this output file just to check if ARES is running well. Just use the same name and just put back up in the file at the end of the file. So you have a readme file that you can see. There's the description of the contents of the package, the system requirements. So there's four libraries that you need to install, and this can be easily done in a Linux machine. So I can show you what to do. So I'm using the latest Ubuntu Linux, and if you're using a Fedora or Red Hat machine, you can also find the package. I will show you the package in Ubuntu. So if you want to install the package, so there are four. There's the cfitsu. You can install this directly within the repositories from Ubuntu. There's the GCC, which is the C compiler. There's the GNU scientific library, and then there's this package to do some easy plots. So in order to install it in Ubuntu, it's very easy. Just do sudo apt-get install, and then you just name the package that have these libraries. So for cfitsu, it's leave cfitsu3 dev. Here is one. It's already installed. I will not do it again. There's the GCC that normally comes installed with Linux. The GSCL, it's leave GSCL 0 dev. You install that also. And finally, the plot utils, that is easy to find. So once you install these, you can compile it very easily. You can check inside the readme file the command to compile. Actually, this command is bigger than it's needed, because if you installed everything like I told you using the repositories of Ubuntu, then you don't need these paths, and you can just use this and everything will work fine. There's some warnings. This is not important, but if you want to get rid of the warnings, you just go to the file, to these lines. So very quickly, the 491 here, just put it is more visible. So line 491, you go here and you put an L there. So 495 L there, and 517, you put an L there, you save it, and then you compile it again, and voila, no warning message. Not that is important, but okay, you got rid of it. Okay, in order to test it, you already copy the output file. So why do I know it's an output file? So if you read the readme and the paper, you know that inside to run ARES you need to edit this file, mine.opt. The name should be this one, and here you have some input parameters for the con that you can set to run it automatically. So there's the fits file. The fits file, you should be careful because the fits file should be in the standard way, and it should be a one-dimensional fits file. And also, if you want to find a line that you are giving the wavelength in the rest frame, then the spectra should be correct in radial velocity. So you have the fits file, you have the lines with the lines that you want to find. Here's an example. So you basically what you need is just the wavelength on the first row of the file. You have the interval of wavelengths that you want to explore. Then you have a specific parameters that are very well described, but the most important parameter here is probably the reg parameter, which basically controls the position of the continuum. So this is all very well described in the paper. Please give a look at it, and also see the following papers where I recommend specific values for the reg parameter for different kinds of signal to noise of spectra. So this is all set. I didn't change anything. In order to run ARES, you just do /ARES, and voila, it starts producing some plots because the input, the mine.opt file is set to show some plots. Here is what you can see. So there's the fit of the lines. You can click on the plots for to disappear, then you can choose to continue with the plots, and voila, again another line to be measured. There's the normalization done here, and then the fit of the line. And if you are okay, if you don't want to see any more plots, you just press plot, and then it makes the measurements. So to see if everything goes well, so you can see now here that the cmine file was created just now. To see if there was some difference between these and the file provided, you use diff, and you can see there are slightly difference, but this is only on the 5th decimal cases. This is probably done to different compilers, which is not really a problem. Okay, so this is a very fast tutorial for you to see how easy it is to install and to put ARES running. And the next tutorial will be to use the output of ARES for my new code that is using calibrations to derive temperature and metallicity using the output of ARES. Thank you.